So first, let's do this the algebraic way. Now, the algebraic way is to realize that if x is some number that's divisible by 6, we can essentially call x 6 times some number k. Now, as long as k is a whole number, then x will be some number that is divisible by 6. Now, we can do the same thing with y. So y has to be divisible by 4, so we can say that y is going to equal 4 times some number m. So to determine which of the following 1, 2, or 3 must be divisible by 24, we simply plug in 6k in for x and 4m in for y and see which one gives us numbers that have to be divisible by 24. So let's start with the first one. So x times y is going to be 6k times our y, which is 4m. So 6k times 4m is going to equal 24k times m. Now, since k and m are both integers, then this number has to be divisible by 24. Now, let's do the same thing with number 2. So 4x plus 6y. So we have 4 times 6k plus 6 times 4m. Now, if we simplify this, 4 times 6k is going to give us 24k, and 6 times 4m is going to give us 24m. So because k and m both must be whole numbers, this must be divisible by 24. And it's even easier if we factor out the 24 to see that this is 24 times whatever k plus m ends up being. So it must, again, be divisible by 24. Now let's try it with number 3. So 6x plus 4y, that's going to be 6 times 6k plus 4 times 4m. So 6 times 6k, that's 36k, and 4 times 4m is going to be 16m. So you want to ask yourself, is there some value that we could pick for k and m that would make this not divisible by 24? And there absolutely are. There are many different integer values that we can pick for k and m that would make this not divisible by 24. For instance, we could say that k equals 3 and m equals, 6. If we plug this into our calculator, we end up with 204. And if we plug that into our calculator, divide it by 24 to see if it's a whole number, it does not go in evenly. We get an answer of 8.5. So we know that 1 works, 2 works, but 3 does not work. So this corresponds to answer choice D. Now the other way to do it is simply by picking numbers to plug in. So you have to pick numbers that follow the rules that they specify in this question. So x has to be a number that's divisible by 6. So why don't we call x 12? And y has to be a number that's divisible by 4. So why don't we say that y is 16? Which of the following must be divisible by 24? So it's as simple as taking these numbers, plugging them into 1, 2, and 3, and seeing which one gives us numbers that are in fact divisible by 24. So let's start with number 1. X times y is 12 times 16. If you do that in the calculator, you get 192. Now to determine if that is divisible by 24, it's as simple as dividing it by 24 and seeing if you get a whole number, which in this case you do, because when you divide it by 24, you get an answer of 8. So this is divisible by 24. Now number 2, 4x plus 6y. So that's 4 times 12 plus 6 times 16. This gives us an answer of 144. So we want to take 144, divide it by 24, and see if it goes in evenly. In this case it does. It gives us an answer of 6. So this also works. Now with both of these, you want to think, are there any exceptions to this rule that I could plug in for x and y that would make this be a number that is not divisible by 24? And in both of these cases, you're not going to be able to find it. Now for number 3, we're going to do the same thing. So we're going to do 6 times 12, which is our x value, plus 4 times 16, which is our y value. Now this gives us an answer of 136. So we want to test this out, see if it is divisible by 24. And in this case, we do not get a whole number. We get about 5.67. So in this case, this is not divisible by 24. And if you can even find one example that is not divisible by 24, then you have to cross it off because it is asking which must be divisible by 24. So that means we have 1 works, 2 works, 3 does not work. So again, if we check out our answers, this corresponds with D.